Yo, what's up, Algebra 2? Um, Welcome to 2021. Uh, I think it's gonna be a good year. I promise we'll be back in school before 2022. Not a lot of seniors here, so I'm going to see you eventually. We're gonna get there, but I hope that the end of 2020 makes people feel good, right? My energy has been up. It feels like the world's turning a bit, so hopefully you guys feel good as well. But yeah, anyway, um, we're going to continue with content. The big gist in this class is we're not going to have the final exam for this first semester. I want to give people a chance to catch up. A lot of you are doing super, super well, but there are a good portion of people who are behind. So I'm going to give them a chance to catch up with the last test we took and the material. Um, and we aren't going to have a final exam. So this is going to be the last week of this semester in this class. And then next week we'll start quarter 3, which is absolutely nuts in my opinion. Um, so yeah, let's just do the math. The good news for people is that we're moving away from graphing for a bit, which I think is cool. And we're gonna do something that is a little bit more exciting, a little bit more challenging. Actually, not really challenging, much, probably just much more interesting. And you'll notice that just by what we see. And what we're doing is what's called sequences. So let me read the question and then we'll do it. And a lot of it's kind of stuff you may have been able to do on your own, stuff maybe you've heard before, but I think it's gonna be a pretty quick lesson. And I just have to kind of teach you some vocabulary, like arithmetic versus geometric sequence. I think it's called arithmetic sequence. Yeah. Okay. Anyway, just look at the following sequence of numbers, 5 numbers. We want to identify the pattern, how we get from one number to the next number, and whether it is arithmetic or geometric. Then we want to list the next 3 numbers of the sequence. So this is going to be pretty easy, but it does ask us to do 3 things. The first thing it's always going to ask us to do in a sequence is identify the pattern. So very quickly, what we see is we have 5 numbers, right? And they're in a list, which we call a sequence. But it's not just going to be random numbers, okay? When you have a sequence, there's going to be some rule that gets you from one number to the next number. And maybe this is already pretty obvious in this example, and that's a good thing because it does get a little trickier. But if I'm looking, how do I get from the number 14 to the number 34? And when I say get from this number to this number, in this unit, we have to think, is there a way that we can add, subtract, multiply, or divide, right? And then hopefully whatever you do here is going to be the same thing we do here. So if I'm looking at them all, they all end in the number 4. And hopefully it's clear that as I go from this number to this number and this number to this number, I'm adding a common difference, right? And we call it a common difference, we'll get there, but we're adding 20, right? This plus 20 gives me this, and then this plus 20 gives me the next number, etc. So the rule in this case is we are adding 20 as we move along in the sequence, right? 54 plus 20, 74 plus 20. The rule is the same the whole time. So if we're going to write the rule as the first thing we have to do, today it's as simple as just saying what it is. So the rule is plus 20. And then we have to talk about the 2 types of sequences. Okay, and I gave you little notes on the bottom, and it's going to be pretty obvious here. But if it's arithmetic, that means that we're adding as you go from one number to the next, or subtracting. And geometric is going to be if we're multiplying or dividing. Okay, so in this case, we're adding. So it's going to be arithmetic. An arithmetic sequence. That'll be a little more obvious when we see a geometric, which is going to have a different rule. But then the final thing it asks us to do is list the next 3 numbers. Okay. So hopefully everyone thinks this is pretty easy so far, but it's going to be the same each time. You figure out your rule, we list what kind of sequence it is, and then we list the next 3 numbers. So have a calculator out because some of the multiplying is hard, but all I have to do is think that the next number is going to be 94 plus 20, right? And then it's going to be plus 20 again. And then it's going to be plus 20 again. So all I really have to do is take 94 plus 20 plus 20 plus 20, and that's going to give me the next three numbers. So I'll write those down here. And that'll be how we finish that question. So I think the only thing that's difficult is that the answers look a little different than what we've seen so far, but hopefully that makes a lot of sense, right? Let's do B because it's another one that's decently easy, another arithmetic sequence. And we know that the first thing we should look for then is there a common difference between every value? And that can go up or go down, right? So we see a bunch of 8s, but they're going down. But that rule is just as easy to write, right? If we see that we're going down by a number, like minus 10 for all of them, that works just as well. 8 minus 10 is negative 2. So in this case, it's still arithmetic because there's a common difference. We're adding and subtracting, but the rule here is we're going down instead of up. So write the rule as negative 10. We're going down 10. It's arithmetic because we're adding and subtracting, and that'll make more sense in a second. And if we want to find the next three numbers, all I'm going to do is take the last number and keep going with the rule. So negative 2 minus 10 is negative 12, and then we just keep going. So that would be like that. So hopefully when you do that on your own, you won't find that extremely difficult. But now let's talk about the geometric series, and we're already noticing some fractions, that kind of thing is going to make it a little harder. But if we're looking at this in my opinion is already much more difficult to figure out the pattern, right? You're looking at 5 numbers and trying to find their pattern. So here, they're not adding, right? Because if we're going from 2 to 8 to 10, that's plus 8. Then we go from 10 to 50, and that's plus 40. Then 50 to 250 is plus 200, right? We can't just add a number to go from here to here and here to here and here to here. So our second big strategy is going to be to multiply. And that's why I don't think this is going to be too bad. So you can first check, right? Like, is there a number that you add the whole way? But if not, maybe there's a number that you can multiply, right? So just try it for the first one. 2 times what number gives me 10? And remember, a good kind of cheat for that is just do 10 divided by 2, right? So I can try the rule by putting in my first multiplication. In this case, multiply by 5. And it's only a geometric sequence if it's going to continue to be multiplied by 5 the whole way through. So once I create a rule for number 1's, the first to the second, I have to make sure it keeps working or it's wrong. So 10 times 5 gives me 50. That's exactly what we want. So hopefully we see that here, the number's getting bigger much quicker. And what's happening is we're multiplying by 5. So first, let's just write the rule. The rule is always going to be one of the 4 basic signs: multiply, divide, add, or subtract. Here, the rule is multiply by 5. Okay? If you have a rule that's multiplying or dividing, that's a geometric sequence. So we'll write geometric. And then let's just write the next 3 numbers. And all I would have to do is take this number and multiply it by 5 3 different times. So the numbers can get really big really quickly in a geometric sequence. I'm getting 6,250, 31,000 and change, and then 156,000 and change. Cool. So that's that. For D, the number is getting smaller. So the first things you pretty much want to notice are, does it look like you're adding or multiplying if you're going up? And if you're going down, are you subtracting or are you dividing? And here we have a bunch of the 10s, and we're losing a 0 every single time, which means that we're dividing by 10, right? So to go from this to this, the rule would be divide by 10. The entire time. Something I just want to note, because sometimes the rule is not going to be, they're not like, using division is fine. But what I want you to realize is that you could also write this in multiplication, okay? So sometimes when you write the sequence a little later, when we start doing some formulas with this, you're not going to want to have a dividing rule. So let's think, is there a way that we could write this with multiplication? And all you would have to do in that case is multiply by a fraction or multiply by a decimal, right? So if you do 100,000 divided by 10, that gives you 10,000. But if you do 100,000 multiplied by 1/10, meaning you multiply by the reciprocal, it gives you the same answer, okay? So if you wanted to write this with a fraction multiplied, you can, and that's gonna be more useful later, but we could say it's multiplied by 10. Hopefully that makes sense to everyone. Good, either way, we're pretty much done with the lesson. And we're just gonna do some harder ones. The second two parts are really easy, right? We know it's a geometric, and now we're just gonna take 10 and divide by 10 to get the next number, divide by 10 again, and we'll get 1/10, or the decimal point 1, and then 1/100. So again, all I did was keep dividing this number by 10 3 times. Okay, hopefully you guys feel good about that. All we're gonna do is talk about if we're seeing fractions and then some negative examples. Here, our sequence looks a little bit more confusing. We have 1/4, 1/2, 1, 2, and 4. Now, if you're weak with fractions, that's okay, and you should keep working with it, because they once they click, they click. But if figuring out how we get from this to this or this to this confuses you, you can always start on the other side, right? Or like near the end of the sequence. So to go from 1 to 2, you add 1, and to 2 to 4, you add 2. So it's not going to be arithmetic, but you can multiply by the same number to get both of these, right? So 1 to 2 is multiply by 2, 2 to 4 is multiply by 2. And then if we think about that rule with our fractions, it works, okay? Because 1/2 times 2 gives me 1, and 1/4 times 2 gives me 1/2, right? If you multiply by 2, it makes the number twice as big, or doubles it. So twice a fourth is a half. I said that quick, but hopefully you guys see what I'm saying. Hopefully some of you might have already started working, and that's great. So the rule here is multiply by 2, okay? Every number is twice as big as the number before. What can be hard is that we see fractions. It's geometric because the rule uses multiplication. Geoseek is fine with me. And then actually finding the next 3 numbers is gonna be pretty easy. You're just gonna take 4 and multiply by 2, 8, 16, and 32. Here we see a very similar thing, but we're going the other way. And the number is getting reduced by 3, or divided by 3, or multiplied by a third, right? 9 divided by 3 gives me 3. 3 divided by 3 gives me 1. 1 divided by 3 is 1/3, etc. That makes it geometric. And then if we want to find the next few numbers, they're going to become more and more fractiony. But something that I think is really cool is if we just keep dividing by 3, that really just means multiplying 3 to the bottom number, okay? Think that the next number here would be 27, right? 27 divided by 3 gives me 9. But if we keep dividing by 3 and multiplying by 1/3, it just makes the bottom of the fraction have more and more multiples of 3. So I don't know how I'll explain that. But all I'm trying to say is that it's 1/27. The next one is going to be 27 times 3 on the bottom. Let me just put in the calculator, right? So we have 1/9 divided by 3, and it doesn't give us the fraction. That's why I don't like the calculator in this case. 1 out of 27. We do it again, and it's going to be 1 out of 81, I'm pretty sure. And then again, it's going to be 243. So we're going to learn all of these. So start getting used to these numbers. 27, 181, 1 over 81, and 1 over 243. These last two are actually not that hard. But that's funny, there's a typo. There needs to be a negative sign here. And all this is that if you see the numbers become negative and then positive and then negative, like flipping, that means that you're going to multiply or divide by a negative number. And the way that works is just think that when you multiply by a negative, it flips the sign, right? So a positive times a negative gives you a negative. But if you have a negative and you multiply it to a negative, it goes back positive. So your rule can have a negative number that you're multiplying or dividing, and all that's going to do is cause the number to constantly go from negative to positive, right? So let's think what number we're multiplying by. 3 to 12, 12 to 48. The number is going to be 4, but it's going to be negative 4. Think 3 times negative 4 gives me negative 12. Negative 12 times negative 4 gives me positive 48, etc., etc. So the rule here is that you multiply by negative 4. It's still geometric. And then I've just have to keep multiplying negative 4 to this value to find the final answer. Come on, I keep messing up. Okay, those are those numbers. Let's do our final one. Here, we have a bunch of fractions, and the bottom is getting twice as big each time. So that tells me that we're actually multiplying by 1/2 or dividing by 2, right? Think that 1/2 is half as small as 1. We keep going down 1/2. And because we see negative, then positive, then negative, then positive, it's going to be a negative, divide by negative 2, or multiply by negative 1/2. So I did that a little quick, but I hopefully feel like that makes sense. I wanted to make sure the video wasn't too long, and we succeeded there. I think it's overall a good lesson. Let me just, I'm concluding while I do the rest of the work. It's geometric because it's multiplying and dividing. And then this number is just going to keep being factors of 2, 16, 32, 64, 128. All right. Good work today, everyone. Proud of you, and welcome back.